Hello and welcome to the Deep Sea podcast, Pressurised, a short, punchy version of our main feed that gets right to the scientific point. If you like what you hear, you'd like to hear the full episode, you can find it in the same feed. And now, to get right to the point. This month's episode, we're going to talk technology, which is key to particularly deep sea science, but if you're doing anything cutting edge, it's going to be key to that anyway. If you're doing something no one's done before, the tools don't exist. You have to often make them for yourself. Particularly in deep sea, you have to be an engineer as well, because you have to build the equipment that will allow you to do the things you want to do. And I think a lot of, certainly for your career, Alan, a lot of things that stepped you ahead was basically being the first person to have this equipment, the first person who could go to these places and get this footage back. But it's a particularly difficult one within deep sea. It's kind of what forces it to be quite an exclusive club, because it's experimental tech, really expensive tech, and it's risky. Inevitably, you have to subject it to an extreme environment, and there's a high failure rate. And it's difficult to get funding for that. It's difficult to win people over. So you had some thoughts about technology, particularly relating to deep sea tech and the hurdles we have to overcome, Alan.
Yeah, I think we're going to talk about the cost of going deep. Mr. James Cameron joins us today from New Zealand. How are you, James?
Very well, thanks. And thanks for having me on the podcast, Alan.
Welcome. So, as part of this whole podcast series, we've already heard loads of different opinions about the deep sea, ranging from it being an almost tranquil and majestic place of natural beauty to something which is, almost likes the touch paper of archetypal human fear. To you, what is it that makes deep sea such a compelling backdrop for both professional storytelling and personal exploration?
I don't see it as a place of fear, although certainly I think you have to be a little humble before the fact and acknowledge the technical difficulties of getting there and operating there. I think that the challenge of it and the fact that it's this vast unknown that's still an unknown in a planet that seems to have gotten very small and very well described, and with Google Maps and the satellite, you can sort of visually explore almost everywhere on the surface of the planet, and it takes that screen of just a few meters of water really to cut out any kind of light or radio frequencies that make the ocean this kind of vast terra incognita. And the deeper you go, the less well understood, the less well mapped, the less well described. So obviously, I know you personally have been fascinated by the extreme depths, the Hadal depths.
Yeah.
What's there? What are the limits of life? For me, it's the great question marks. It's what's down there. How do we take our lights down there and our sensors down there and see it? And in my personal case, as an explorer at heart, I want to see it for myself. I believe strongly in bearing witness and actually seeing it, because it has an effect on you, on your consciousness, on your emotion. And that's part of the drive.
Yeah, that was going to be my next question, because you're in quite a unique situation where what are your motivations for this? Because in one respect, with your explorer hat on, it's you immersing yourself into this environment. But from a filmmaking point of view, you're trying to take that environment and give it to somebody else.
Yes, exactly. Yeah, I think where people have consistently gotten it wrong is that they think my primary focus in life is to make entertainment films for mass audiences. And it really isn't. My primary focus in life is curiosity and wherever that takes me. So when I go into the ocean, it's as a documentary filmmaker. And I've had a surprisingly large number of arguments with journalists who say, oh, no, come now. You're just down there trying to find new alien species so that you can make a better Avatar movie. Are you kidding, mate? I mean, pay attention here. I've got the best designers in the world making up aliens left and right, and nothing that we do can compete with the imagination of nature itself. So I'm down there as a seeker, as a sojourner, as a supplicant, if you will, before the majesty of nature in all its glory. That's where I worship. That's my church. It's really got virtually nothing to do with making a better Avatar movie. I'd say it's more the other way around. If I make a good film and people go see it, I get money. I take that money and I put it into developing submersibles and deep ocean robotics and cameras and lighting systems and so on.
So the theme, if you like, of this particular episode of the podcast is technology. With that in mind, when we're talking about deep sea, we're talking about about hadals at depth and things like that. You're looking at high pressure, massive distances from the surface, cold temperatures, everything which is challenging. So do you find the technical challenges something of an obstacle, or do you see it as part of the enjoyment of the journey?
It's absolutely part of the pleasure, solving the problem. Now, just as you know from your experience, you can have some incredibly vexing days at sea.
Oh, yeah.
Where your tech isn't working, but you learn from those days and those moments and those technical failures. But for me, a big part of the excitement is the challenge of creating machines that can go into, I would say, arguably the most hostile environment on Earth. I think it's easier to build a spacecraft than it is to build a deep ocean system. First of all, spacecraft are much better funded than we are. But secondly, you're dealing with pressure regimes that butt right up against the edge of material science itself. When you're dealing with hadal depths, you're at the failure level of the actual materials themselves. Electronics despise seawater, because it's an electrolyte, a conductor, and it fritzes them out. The complete inability for electromagnetic radiation to propagate through the water. So you're entirely dependent on acoustics for navigation and comms, unless you can get a fiber tether. When you're dealing at hadal depths, it's pretty hard to run a big fat armored cable 10 miles or so, because everybody think, oh, well, it's only 7 miles, but you've also got scope on that cable as it gets deflected by currents and as the ship moves around at the surface and all that. You're literally up against the tensile strength of the steel in the cable itself. So these light, elegant fiber optic cables work, or fully autonomous vehicles. Then you get into some really interesting areas of tech where, as we expand our ability to have AI and deep learning and machine learning and so on, we're going to build smarter and smarter vehicles to go down there and perform more and more of the tasks that previously required kind of real-time human-in-the-loop control system. So that's an exciting development.
I think it's interesting when you speak to engineers who specialize in corrosion as well. So they list all these things,
Yes.
and on top of everything else, the sea is also trying to eat your gear.
Sure. And so you have to be careful where you put your sacrificial anodes. And I love the tech. I love the challenge of the tech. I'm not an engineer officially, but I've certainly managed enough engineering projects over the last 25 years to say that I know enough to be dangerous. I can run a good group of engineers toward a goal. And so that sort of project management skill is a learned art.
But on those lines, I was going to remind you that a few years after you did the Deep Sea Challenger, I remember we were talking about trying to reuse some of the technology that was developed through that project. And I put together this enormous EU grant to build these crawlers for hadal depths and all the rest of it.
Yeah.
And I remember the secretaries in the office when I came with this grant proposal, they're like, oh, James Cameron, that sounds like the guy who makes Avatar and so on. And I'm like, it is. But the point is, we got 4 reviews back. 2 of them said, this stuff is brilliant because unless someone goes out and does this kind of stuff, we'll never be at the point of hypotheses-driven science.
Right.
The other 2 said, this is rubbish. This is not hypotheses-driven science. And, and this is something which has plagued everything we do. So my question to you is, where are we in terms of exploration and society's sort of take on what exploration is? I mean, the days of just going somewhere for the hell of it seem to be over. But yeah, they were extremely valuable days.
Sure. I mean, the idea of hypothesis-driven science is that you already know a lot. You can extrapolate, maybe 5% beyond what you know and expect a result. Now go find the result you expect. So it's basically what I like to call confirmation bias science. You already know what's going to happen, and you only look at the data on the basis of what fits your hypothesis. So there's an innate trap there. I think it's much more interesting to just go and look someplace nobody's ever been. Look at the discovery of hydrothermal vents.
Yeah.
There was no hypothesis that existed that I know of, that those chemosynthesis-based communities existed down there. Somebody went down there, took a look, and said, holy look what's down here. We didn't predict this. We just went down to see what was happening at hot vent sites at spreading centers. It was a geology expedition that suddenly turned into a biology expedition.
The next question I was going to ask was, a lot of your films deal with quite cautionary tales about technology or unchecked advancements and things like that. And so what are your thoughts on things like deep sea tourism and industrialization and deep sea mining? Should we be pushing for a greater presence in the ocean and then run that sort of apocalyptic film risk of getting it wrong? Or are you more for the more people in the sea, the more people will appreciate it, the more we might look after it? It's a really difficult question.
setting aside the depth factor, we're not leaving the sea alone. We're raping it just about as fast as humanly possible. Wherever there's a penny to be made, we're there. So we've pretty much cut huge swaths through the food webs. We've basically wiped out about 90% of the apex predator biomass, and now we're working our way down the kind of trophic levels practically to the krill. A lot of our runoff pollution has destroyed primary production in a lot of these eutrophic dead zones, 400 dead zones at the mouths of major rivers. We're basically using the oceans as a toilet in an unclosed loop. It's just open circuit. We're just dumping our sewage and our industrial waste. So I don't see how much more damage we could do to the ocean if we literally sat around and said, okay, guys, how do we screw up the ocean? Yeah, I think it's probably naive to think that if it ever becomes economically viable to mine the deep sea, that we won't do it. Of course we're going to do it. We mined every other damn place. We're destroying the Amazon headwaters. We're destroying rainforests and indigenous populations in, South America with gold mines and various other mining operations. So, I think as a deep sea community, it would be incumbent on us to try to at least get some guidelines in for how to do it with the least impact biologically to some of these ecosystems that we've barely studied. Some of the ones along the mid-Atlantic ridge and some of the other popular spreading centers, the East Pacific Rise and so on, are pretty well described. But such vast amounts of the deep ocean that just haven't even really been looked at with any kind of proper funding. It'd be nice if we understood it before we destroyed it.
So sticking with the technology, and this is a technical question I just wanted to ask you for my own selfish reasons. And that is, we spend a great deal of time and money developing or buying cameras to film for scientific reasons. But I think one of the things that I think we as scientists don't truly understand is the art of illumination, right? So let's just forget the big philosophical questions. Do you have any tips, or what is the trick to lighten up underwater in the dark?
Well, I think that, the first rule of visible light photography is take a lot of light, so then that you start looking at the power envelope of your vehicle and what it can support and for how long. And of course, with LEDs now, we have much more efficient lighting in terms of power efficiency. Obviously, there are other spectra to look at, and imaging and LiDAR, blue-green laser, and things like that, which can reach farther. But if you're just talking about visible light photography, obviously you want sensitivity on the camera and good resolution, and you don't want to light through the same water column that you're shooting through. That's the first rule of any underwater photography, regardless of depth. When I was shooting the Abyss, exactly the same rules that I had in a dark tank that was only 60 feet deep, I have the same rule set at 10,000 meters. Your field of view of the camera, you should try to limit the amount of water that it's looking through that's used to light the subject. So what you want to do is create a long baseline, move the light away from the camera as far as your vehicle will allow. And everybody freaked out when we built an ROV, a little ROV for going inside shipwrecks and into tight spaces, where we put the camera all the way on the left of the vehicle. They said, you can't drive an ROV with the camera not on the center line. I said, do you sit in the center of your car? Of course you can. But the objective there was to take, we only had a 14-inch baseline. So we put the camera all the way on the left side, and we put the main light all the way on the right side. In fact, we made a vertical strip that ran up the face of the vehicle so that we kept the lights projecting through the least amount of the water column that you were looking through. And this limits backscatter. And you never know what the turbidity of the water is going to be. Fortunately, in the very deep ocean, it tends to be pretty crystal clear. But if you stir up the bottom, you'll have a backscatter issue. So you want to have power efficient lights. You want to have a lot of them. You want to have a power envelope on your vehicle, whether it's robotic or human piloted, that's big enough to support your lighting.
It's funny, a while ago I was talking to Kelvin McGee, who I think was with you on one of the Titanic expeditions. He was telling me about this lighting rig that you've built. I think you refer to it as a second sun. It was some enormous, huge lighting rig, and it's like, well, if you're going to light the Titanic, you need a big light.
The Titanic is a tough subject because it's rusted steel, so it's basically orange-red in color. As you know, red and orange are the first colors to drop out, to be naturally filtered out by transmission through water. So let's say you're trying to light a couple of 100 feet of Titanic, which is only a small fraction of its total size. You're putting out light 150 feet away, and then it's got to come 150 feet back through the water. That light started out as white light, By the time it got to the wreck, it was now blue. What remained of it, the blue photons were getting through. And then it's bouncing off the Titanic, which is orange, which means that it's absorbing blue light and reflecting red, but it's not getting any red light. Now it's got to come back through the water column, that red light, what remains. So you're down to now 2% of your original photons. Now you're coming back that 150 feet and it's filtering out, 90% of your red photons before it gets back to the sensor at the camera. You basically wind up with nothing. So we said we have to take a 1 metric shit ton of lights into the deep, that was our goal. I said, I want every light that anybody has anywhere that can survive that pressure. And so we rounded up the 1200 watt PARs that were available and we bolted them onto a purpose-built ROV that was basically a big slab of syntactic and a bunch of old bits of kit that they had lying around at the engineering company. And we made a chandelier. And when it came on, it lit up the Titanic. It was actually quite impressive. That's how you light the Titanic.
It's fascinating. I never thought of that, the whole thing. Of course, it's rusty, it's red, it's the worst possible colour to film. It never really dawned on me before that would be a problem. Of course it is.
The only saving grace there was that there had been a slow deposition of proteinaceous snow, over the entire wreck. So we were able to get an image at least off the top surfaces of the ship.
With nearly 9 years of hindsight on the Mariana dive, is there one moment in that whole expedition that is the thing that you remember the most?
The way I operated the sub, I had a viewport, but we had a kind of an unusual configuration where I was in a seated, cross-legged position, and I wasn't driving like a normal submersible pilot in a kind of reclined, supine on my stomach type position. So I was operating through an HD camera with a wide lens, a 4K image. But I had it set up such that I could unship that camera, unmount it, and swing it out of the way and get my eye to the viewport, which took a bit of contortion, and a couple of years of yoga paid off to be able to do that, because this whole sphere is only 3 feet in diameter on the inside, and get my eye down to the viewport and just sit there and literally bear witness with the naked eye to arguably the most remote place on planet Earth. I remember looking out, and the bottom is very featureless there. It's like new fallen snow, which I think is actually an apt metaphor, because I think it's all been stirred up by some big seismic event in geologically recent times. And it hasn't had a lot of biological activity to mar the bottom with worm tracks and various invertebrate tracks like you normally see. I mean, you've seen a lot of benthos. You know that at least at abyssal depths, you're constantly seeing the records of activity. Even if the animals aren't physically present. And I didn't see that. I saw just very sparse indications of that. So the sea bottom doesn't change very rapidly. I just felt like I was looking at something absolutely untouched and no human eyes had ever seen, and felt that was a gift.
Yeah.
I always feel that in these exploration enterprises, you have to train yourself to stop and smell the roses. You have to train yourself to stop and bear witness, because I get very technical. I get very much like I'm there to solve a problem. I've got to do this. I've got to do that. I've got to hit all the things on my dive checklist. And sometimes you just have to stop and look and let it seep into you, where you are and what where you are means. And so it's that moment, I guess, when I just looked out the window and just sat there for a few minutes.
So finally, just for fun, assuming there's no restrictions whatsoever, anything goes, what bit of deep sea technology would you want, no matter how far-fetched?
Now, you're talking to a science fiction writer. I'd love to have 2-ton maximum glass-sphered solo or two-seater subs that could be deployed from any ship of opportunity very easily without a big complex handling system that are either full ocean depth or at least 6,000 meter rated. I think that's a doable thing. Just need to learn more about glass technology than we currently know. I think if you want to talk far-fetched, like really out there, I would like to have my consciousness embedded into a robot that can go anywhere. Now, either by some kind of electronic transfer into an AI-controlled vehicle, or maybe more in the near term, kind of like a cyborg. Take my brain, stick it in a machine, let me go anywhere. I'll start with walking around the seafloor at any depth I want to go to. And then they're going to launch me to Europa, and I'll do the same thing under the ice there. What I'm visualizing is a crab with thrusters. Right. So it can fold its legs up like any self-respecting crab can do, become more streamlined, thrust around, and then deploy the legs when you want to, and walk around, whether that's on a rocky substrate or... Yeah, so there you have it.
That's the best answer I could have hoped for. And with that in mind, Mr. James Cameron, thank you very much for coming on the Deep Sea podcast.
Okay, well, it's great talking to you again, Alan, as always. And, I know you're a true believer and you've done amazing work. Just keep it up.
Brilliant. Thanks very much. Honestly, I really appreciate it. I understand you're really busy and everything else. And it's great just to chat to you again. The crab thing is brilliant.
Well, you're going to see it in Avatar too.
Oh, really?
Yeah. I had ulterior motives as I was working with the designers on that.
One of the questions I was going to ask was, when you develop these technologies for the movies, is that just stuff that you really want?
Yeah, I just want to build it.
Yeah. If you can't have it in real life, you might as well just make it and put it in the films and go, yeah, I want a giant floating crab thing with my consciousness in it. That's actually just a wish list. Brilliant.
Yeah, exactly. As you do.
Yeah, why not? Yeah.
Hello, my name is Don Walsh, and I've been an ocean engineer for nearly 6 decades. I'd like to give you some ideas or thoughts I have on ocean engineering and what it means to me. First of all engineering, whether it's in the sea or on land, is really an art form. Sure, it's not like music or some kind of graphic arts or painting, but it is an art. Well, let's define ocean engineering in a very simplest of terms. It is the engineering arts and sciences getting wet. In other words, applying existing engineering arts and sciences to ocean problems. Now, what is the role of ocean engineers? It really is to design and construct things that do useful work in the oceans. But ocean engineering depends on the inputs from ocean science or oceanography. In essence, the end product, if you will, of ocean sciences is predictive information. That is, the scientist observes some phenomenon, develops a theory to try and explain it, and then does experiments to test the theory and to see whether or not it's repeatable. From that comes predictive information that the engineers can use to intelligently build machines or equipment to operate in the oceans. And of course, there's a pretty good feedback loop there. The feedback loop is to also build machines and better equipment for ocean scientists to use. So that new instrumentation, new sampling devices, and so on are all a result of intelligent engineering based on scientific input and also the requirements for trying to do scientific work better. Now, there are a lot of ocean engineering schools or curricula around, and some of them already go up to the level of PhD. However, it's not required. You think about the old days when there were apprenticeships to carpenters, to shoemakers. You studied for several years under a master in that particular trade or craft. And it's the same thing in ocean engineering. A lot of ocean engineers, some very fine ones, never had formal engineering training. In fact, James Cameron is an example of this. I consider him to be one of the finest shade tree engineers I've ever met. Jim and I first met in the early 1990s when he was considering developing a one-person submersible to dive to the deepest place in the world ocean. I think that was around 1991. Then over the years, we interacted as he was developing this program. And finally, in 2013, I was able to go out to Australia and see his manned submersible, Deep Sea Challenger, when it was under construction at Sydney. And then a couple of months later, I was invited to be on his expedition to Challenger Deep. And I actually spent 10 days at sea on board the mothership and observed him as he dove into the Challenger Deep. I was the last person to talk to him before he shut the hatch. And all I said was, have fun, because I certainly had fun 50 years earlier when I had been one of the first 2 people to make that dive to the deepest place in the world ocean. And then when he came back up, when he surfaced at the end of the dive, I was one of the first people to greet him, along with his wife, Susie. Now, while oceanography gets the big play, that is the big play in the sense of being attractive careers for people who want to go into work associated with the oceans and to scientific work. Everybody wants to be a modern-day Jacques Cousteau, who was a person I'd worked with in earlier times, and I still consider Jacques to have been one of the great proponents of popularizing oceanography. Everybody would watch those wonderful programs he did and say, I'd like to be like that when I grow up. And guess what? That's what Jim Cameron told me once. He said, when I was growing up in Canada, I watched the Cousteau programs, and I said to myself, someday I'd like to be the modern day Jacques Cousteau. So that's high visibility. People want to do that, but we forget about science standing alone is not all that useful. It has to be applied to problems and needs of society or humankind. And that's where ocean engineering comes in. But it's not as glamorous as ocean science, and yet it's a very vital function. So I guess in summary, all I could say is, so all you would-be ocean engineers out there, come on in. The water's fine. Thanks for listening.
And that concludes this pressurized version of the Deep Sea Podcast. If you've enjoyed this episode and you'd like to go into some more detail, you can find the full episode in the feed. Just match the episode numbers. We'll deep sea you next time, and I abyss you already. The Deep Sea Podcast is supported by our company, Martus Oceanic. If you'd like to explore the deep sea for yourself, we can provide the technology and know-how to allow you to do that. Or if you'd like to bring the deep sea to your audience through storytelling, fact-checking, or presentations, we can help with that as well. We want the deep sea to be accessible to everyone.